Still, we are talking about dynamic programming, and I'm going to solve another problem which is called edit distance. What is this problem? Assume you have two strings, A and B, which each string is going to be a sequence of characters, right? And I want to find the edit distance between these two strings to convert the first one to the second one by applying some operation. So I'm going to minimize those operations. What are the valid operations for us? Add, delete, or change. There are many use cases for this problem. For example, in a spell checker, you got a string which is not in your dictionary. You want to actually find some other possible correct word instead of that, and you want to actually suggest them. Basically, you get the one which has the minimum distance, right? So you calculate the edit distance there. So let me show you an example. Assume you have a word like a snowy and you wanted to convert it to sunny. You wanted to calculate the edit distance between snowy and sunny. I'm actually showing you three different cases of calculating the edit distance. In the first one, I'm matching S and then I'm adding U. So one operation I have applied here, add. N and N will be matched, so nothing. O has been converted to N, so one change here. Here W has been removed. And Y has been matched. So in total, the edit distance based on this case is going to be 3. So can I get something better? I'm actually showing you some other cases as well. In this case, I have added S, so one add here. I'm changing S to U, so one change. Matching N, so no operation. Converting O to N, so it's going to be remove. And then removing, it's going to be change as well. And then you are removing W here. So under operation here, and then you match Y. So the number of operations that you applied here was 4. And the last one, match S, convert N to U. So one change O to N, change W to N, change, and match Y. So again here we have 3. And basically the optimal answer here is 3, the distance between snowy and sunny. So how we can solve this problem? Again, I'm looking for some recursion, some reoccurrence relationship. I need to define some sub-problems in that reoccurrence relationship. So very similar to many other examples that we have seen, you might be able to define different type of sub-problems, but not all of them are going to be useful for you. For example, in the interval scheduling, in the subset sum knapsack, it was possible to define some other sub-problems as well, but we just stick to those sub-problems that we need them. So this is, one thing that you always need to keep in mind. So how we approach a problem and solve it using dynamic programming, the very first approach that comes to my mind is that I try to solve it in a form of a exhaustive search. And when I'm doing that, I try to find some repetition and define define some structure, some organization, some structured form of the sub-problems. And another approach which is going to be helpful a lot is that after you have seen a couple of examples, different problems that has been solved using dynamic programming, usually when you solve a problem, you will find some similarity between the problem that you're going to solve, and one of the famous ones that you have solved before. So if you think about this edit distancing problem, you will see that kind of this problem is going to be similar to the that problem of longest common subsequence in terms of how we define the sub-problems. I'm going to actually use exactly the same approach here. In the longest common subsequence, we define the sub-problems to be, just define it over some prefixes of the string, right? The sub-problems was the prefixes of the original string. So, for example, you have the original string was from, a sequence of characters from 1 to n, right? And the other string was from B1 to, again, for example, BM. And the smaller subproblems that we can think of is, find the edit distance for all the prefixes of the first one and all prefixes of the second one. So it's just like all the prefixes like this that I will change, will vary from 1 to n, and all the prefixes of the second string that j will vary from 1 to m. The lookup table that we define is going to be d of I and j, which basically tells me that what is the minimum edit distance between this prefix, the prefix of length I from the first string, and the prefix of length j from the second string. So in this way, the answer for the original problem is going to be at d of n and m, which tells me both strings are complete. So the first string is going to have n character, the second string is going to have m character. So if I'm going to actually show you the table for that, it's going to be something like this. This is that table of d of I and j that I have been talking about. And what I'm actually doing here is that you have two strings, right? A and B. In this case, both of them have the same length, but it is just the example. It doesn't really matter if the length of your strings are the same or no. So this is going to be A1, A2, A3, A4, A5, right? And this is going to be B1, B2, B3, B4, B5. And this table is actually just explaining, each cell here is corresponding to one prefix of A, a prefix of A and a prefix of B. So for example, if I am filling a cell like this, it is corresponding to the substring S from A. This is a prefix of A, which is just including A1, and another prefix of, a prefix of B, which includes from 1, we can see that this is the column of 3, so it's going to be S, U, and N. So it's just like, if I have these two strings, what is the minimum edit distance between these two strings, right? Which each of them is going to be a prefix of the full one. So the full answer for me is going to be here, right? Which is telling me what is the edit distance between the full string A and the full string B. Okay, so now let's think about the recursive relation for it. in general, if you have two prefixes, two strings, whatever it is, for example, from A1 to AJ, this is a prefix of the first string, this is a prefix of the second string. I think in my relation, I wrote it as I. So let's just change it to I. And this one as J. Okay. So when you wanted to calculate the distance between these two strings, there are, you're going to basically make, use some sub-problems which are smaller, right? If you are going to make a smaller sub-problem, you are removing something from the end. Okay, so you make it actually, you decrease the value of I or you decrease the value of J to create a smaller sub-problem. And it is exactly like the way that we solve the longest common problem, that we approach the string from the end of it. So if I am comparing these two characters, AI and BJ, there are 4 possibilities for me, right? So I'm actually approaching these two strings from the end of them. If they are equal, you will match them, okay? So it is very clear that if they are equal, the answer that you get is going to come from, you're going to actually think about if they are equal. It will be d of I minus 1 and d of j, d of I minus 1 and j minus 1. Okay. The other actually operations that you can have is that maybe if they are not equal, in fact, there are 2 possibilities. Either you are going to remove a sub I, right? Or you are going to you change AI to BJ, or you are going to add BJ because you don't have this one, right? So these are the 3 possibilities. Either you are going to apply add. I should start it from remove. Remove, change, and add. Remove AI, change AI to BJ, or add BJ. Okay, so in each of these cases, you are changing the problem to something different. So that the problem of D of I and J will be changed to, when you are removing I, it's going to be whatever is the edit distance for I minus 1 and J plus 1, because you are applying an operation, right? Or you are changing I to AI to BJ, so the sub-problem will be I minus 1 and J minus 1, again plus 1 because of the cost of that operation change. Or you are adding this character BJ, so it's just like BJ has been matched and you are getting getting rid of that one. So it's going to be I and J minus 1. You are getting rid of that index. You are adding it. And what is the cost? The cost is 1 for adding that. So you are going to have 4 cases. This one for remove, for change, and for add. You will actually calculate all of them, compare all of them, get the minimum, and you update d of I and j with the minimum of this. So it's going to be something like this, that when I am calculating d of I and j, I have three cases. Maybe this slide is going to show you, the written form of it better. That you are either, this is the first case that I explained. This is the first case, that if I and a sub I and b sub j are equal, so you match them, right? So you are going to have a smaller prefix and a smaller prefix here. You can also change a sub I to b sub j. So in this case, again, you are going to have a smaller prefix in both cases, but you are going to add the cost 1 to that, and you are actually can remove because you are converting the first string to the second one. You are converting from A to B. So in this case, you are getting rid of A sub I, so you are making this problem smaller, and the rest of it is the other. Actually, you're making this string smaller, the first one, and the other string, the other prefix is not going to be changed. Or you are going to add bj. So in this case, it means that I have added bj, right? So the other problem that I have to solve is edit distance between the prefix of A1 to AA and this prefix of characters, B1 to BJ, because I have already added BJ. It has been matched. So all of it has been written here. This is going to be the complete, kind of the complete recursive relation. How can I I haven't written the full pseudocode for that. It's going to be very similar to what we have written for the longest common subsequence. Just this is the recursive relation that we are going to apply. So let's just apply this one over an example. Probably I need to clean up here a little bit. I'm going to just go with you over this example for just some steps. It makes it more clear probably. So this is the table of d of I and j we are filling. This is the optimal, the final answer that we are looking for. And how we fill this table. I'm going to fill the table from, all of the rows. I'm going to fill it row by row and column by column. It means that from from top to down and from left to right, actually. So at the end, you are going to reach to this cell as the last cell to fill. One thing that I can do is that, what is this first column and first row tells me? It tells me that the length of string B is 0, or the length of string, the row tells me that the length of the string A is 0, and the column tells me that the length of string B is 0. Okay, so it basically means that if I am filling this cell, it means that you have an empty string as A and an empty string as B, right? So the edit distance here is going to be 0. This is something that I can do as an initialization. I'm going to fill the first row and the first column first. The other, let's look at the next cell. What this cell tells me, it tells me that the first string is empty. This is a valid prefix, right? So it doesn't actually include anything. But the second string is going to actually have the first character. In this case, for me, it is going to be S. What is the edit distance to go from an empty string to S? You need to add S, right? So this is going to be 1. And similarly, you can actually just extend to the rest of them. So the answer for the second, third cell here is going to be 2. It's just like, what is the edit distance to go from an empty string to a string SU? What is the edit distance to go from an empty string to edit this to a string SUN? So this is going to be 3, this is going to be 4, this is going to be 5. So in all of them, basically you need to add, if you are going to have a complete string here, and you have an empty string, from an empty string, how you can convert it to a complete string of B, you have to have, for example, m number of add, right? You have to add all of those characters. Similarly, I can fill this column. So this cell is going to tell me that unlike the previous case that I had, this time it is telling me that the string A is, for example, S, the only character. This is index 1. And the second character is empty. How can I convert from this string to this string? I have to remove that, right? So the edit distance here is going to be 1. Here it is going to be 2, 3, 4, and 5. So after this, now I can go over all of each actually rows and fill them from left to right. So let's look at, let me actually just clean up some part of this, make it more readable. Okay, now we are working on this cell. How can I calculate that? I'm going to exactly look at the recursive relation that I have. The recursive relation tells me that if you are filling D of I and J, there are 4 possibilities. What is D of I and J? It's just like the strings, if I write it down completely, it's just like you are converting this prefix to this prefix. Intuitively, you know that it's going to be, the cost is going to be 0 because they can be matched. But I wanted to go with you as we are running the algorithm, just go over the recursive relation. So D of 1 and 1. There are 4 cases for this one. Okay, so the first case is that AI equal to, A1 in this case equal to B1. So if it is equal, you get the answer from D of 0 and 0, right? Without adding anything. If you are going to go with, this is the case of match. The next case that I'm going to do is remove A1. If you remove A1, it means that you are going to remove A1. In that case, you are going to have 1 plus, what is the next subproblem that you can have? You are removing, you're actually decreasing I, so it's going to be 0 and 1. What is this one? Later on, I'm going to actually check all of this. The next case is that you are changing, let me just write it as C. You are changing A1 to AB, so the answer is going to be 1, the 1 for that operation that you apply, plus D of 0 and 0. Again, you have converted that character A1 to B1. And the last one is adding. So in this case, adding B1. In this case, you are going to have the cost of 1 for adding and get the optimal answer from, in this case, it's going to be 1 and 0. So basically, you are getting the answers from here, here, and here, and you compare them, get the minimum. This case is going to give me the minimum answer, right? And I can only apply it because they are equal. I mean, these characters that I have, A1 and B1, both of them are equal. So the answer for me here is going to be 0. Let's just look at this one, the next cell. Again, maybe I write it this time here and try to write it more clean. Okay, I'm going to fill D of 1 and 2. It is corresponding to this problem that you have S in A, that you wanted to convert it to this string, SU. So what are the different cases that I have? If AI is A1 is equal to B2, I can get the answer from D of 0 and 1. But it is not the case, so basically it is not applicable. The other cases is that I can remove A1, so the answer will be 1 plus D of 0 and 2, or I can convert, I can change A1 to B2, so it's going to be 1 plus D of 0 and 1, or I can add B2. Again, in that case, I can add B2. 1 plus D of 1 and 1. Okay, if you compare this solution, this is not going to be, this is out of question, right? I cannot apply this one because they are not equal. For this one, the answer is going to be, okay, I have the answer. As you can see, again, I'm getting an answer from this side, from here, and from here. And just compare that, which one is going to give me the optimal answer. So this one is going to be 3, right? Coming from here, this is going to be 2. This one, 0 and 1. This one is going to be 1. So here I'm going to get 2. And this one, I am going to get the answer from here, which is 0, right? So 0 plus 1, the answer is going to be 1. Minimum among all of this, it is telling me that the edit distance here is going to be 1. And where I am getting that answer, you are getting it from here. You are getting it from this side. Okay, I can probably just remove all of the other things that I have. So now it is more clear that, let me use the same color everywhere. Here you get the answer from this subproblem, and here you got the answer from this subproblem. You can continue and see that this is very similar to the approach that we had for this longest common subsequence. I mean, try to fill this table. Here you are looking for the minimum distance. In the longest common subsequence, you are looking for the longest, so you are looking for the maximum length of a common sequence. That's the only difference, but maybe sometimes you actually feel it's going to be confused. So just try to run it over this example. It helps to understand and digest the algorithm more clearly. What is the time complexity? Let's actually finish the analysis of this time complexity. Okay, I am filling a table. The table is going to be of size whatever is the length of A, that we call them it N, and whatever is the length of B, it was M. So I have a table of size M to N, and how much actually computation I'm doing to fill any of these cells. As you can see, I'm looking at 4 other possibilities. Only 4 other possibilities. That's it. This is going to be constant amount of computation. So the total time complexity is going to be O of Mn, exactly similar to what we had for the longest common subsequence. So I'm done with this example. You can, I'm actually recommending you to fill this table, and then also there's another example, polynomial and exponential. Try to find the the edit distance using this algorithm that we discussed, and fill the table for these 2 examples. I'm sure that if you try to understand any algorithm, if you try it on some example, if you trace it on some example, it helps a lot to understand what the algorithm exactly do, and it will help you to just take all of these different pieces of information that I gave you or you read in your textbook, to put all of them in place. So these 3 problems that we have discussed for this case, the job interval scheduling, the knapsack, and also edit distancing, are 3 sections of the textbook DPV. You can read more about them here. In the textbook.